sunflower or
Good evening.
Hello. How are you, Austin?
I'm good.
Good. Hey, Jared.
How's it going?
Good. How you doing tonight?
So, question before we begin. I went through all the material for today and understand, I mean, they showed a lot of SPSS files and ways to calculate things. I couldn't find the, is it under linear regression? It's not linear regressions.
Yeah, it is.
Yeah, it is.
It is the linear regression?
Yeah, it took me a long time to figure that one out, too. But it's under the quantitative inference procedures.
Yeah, and it just, there's just like a lot more crap that they have on this than was in the slides or in the page or anything.
Absolutely.
So that's why I'm like, kind of blown away.
You only get two numbers for this 50.
Say that again.
You only need two numbers from the thing, but they give you like 50 numbers.
Oh, yeah, absolutely. Yeah. You need the R's and the
standard deviations.
Yeah, and the correlation, the covariance, not correlation. That's pretty much it.
Yeah, then next week I'll do probabilities with it.
Yeah.
Okay, so that makes me feel a little better. I wonder if we can just enter in a mean and stuff, or it's just all going to be data. Oh, I guess you need all the data points for the chart.
Yeah. Yeah, you need that to establish the scatter diagram, or whatever we call it.
Yep. Cool. Hey, Jared, did you get the email back from the instructor?
Yeah.
Did you say just that? Submit it?
Yeah, that's what they said. I'll just we got this one little extra thing. You just have to look in the section where it's at, and it'll tell us how to submit it.
Yeah, she said to me to send her a copy of it because it doesn't let you submit anything online. So it's pretty simple. It took like 2 minutes.
Yeah.
So. Ooh, I don't know what to.
So I think Zach's not joining us tonight. Was that Zach or Jared that they got a notice from? So maybe we'll wait a minute for Jared to come along and we'll jump into this. It looks like it's pretty straightforward.
Okay, and Ian, you're gonna do the describe the data?
No, I'm not. I'm doing the PowerPoint. Let's see who's doing describe the data.
Let's see.
That's you, Jared?
Yeah.
Okay, I'm just reading through, and it says you need to like have graphs and stuff. And I assume that, I mean, you're pretty resourceful and creative enough to, I think, make some good visual data.
I'll create a bar graph.
I mean, as far as calculating the data, has anybody stuck it in the ANOVA yet to see what the numbers look like?
No, I'm responsible. I can do that. Looks like yellow's the loser and blue's the winner.
Cool.
I love that in my wife's face because judging off of our little bag, it means one, and she's out on the green, but on the blue. Judging on the whole data, I'm the blue one. Right, I won the bet.
Nice. So while we were, oh, go ahead.
Oh, what I find to be interesting is that I think brown had the most zeros, but yellow still had an overall less.
I was looking at your data and I was like, wait, there's zeros. I didn't know you could not have a single color at all.
Yeah, your data will be a little more skewed because it's all going to get rounded up to at least one.
Mm-hmm.
But
Yeah,
other people,
I had several packs that had 0 in them.
yeah.
Yeah, that was probably because I bought the regular packs.
Yeah, and everything got rounded up, I think, is why yours didn't have any zeros. That's interesting, though. Yeah. Blue's the winner. Blue's the best color.
Mm.
I thought there was there is a study, and it showed that brown is actually one of the most common colors. It was
Yeah,
actually,
I thought I'd heard of that too.
yeah, like it was like 8% more brown or 10% more brown or something.
Yeah.
Yeah, it would be an easier color to make.
So we're really just, all we're doing is, so our null hypothesis says that they're all equal, and
The other one says that there's
the other
that
one says
one.
says that they're not equal. So we don't even really need to decide which one is unequal, do we?
No, I think it's, and with an ANOVA, isn't it just that one, there is at least one that is
Yeah.
not within like a certain range or something?
Right, right.
Or
So I guess making inferences, I guess we could go a little further when we get to the inferences part and say, well, based on the means, it looks like maybe blue is the winner and yellow is the loser. But
yeah, because yeah, blue could, or let's see, there's blue and there's one other one that was kind of large. Blue and orange, I guess, were the two highest ones.
yeah,
It's really weird. I've never thought of orange having a lot. And then yellow's on the other spectrum.
yeah.
Or would those be considered outliers or not correlated or whatever?
Yeah, I think they would because they would have different means. It wouldn't necessarily have to be high or low as long as they were different from the other means. Right? I think that's the way that works.
Yeah. High or low, yeah. That they're too far deviated.
Right, right.
Oh, yeah. It's under the
Cool.
homework.
Now should we jump into the
Yeah,
homework stuff?
I say we jump into it, and if the other Jared joined picking up pretty quick, so.
Yeah, sounds good to me. All right, so let's see.
Preemptively, I'm just going to... Let's do it.
Okay, so let's see. This is the preparation assignment. So I'll read number 1. Describe the role of the correlation coefficient. What does it measure and what are its bounds? Well, its bounds are -1 and... Am I on the right question?
The correlation coefficient is used to quantify... Oh, whoops, sorry, that's the homework. I'm like looking at it, or the quiz. You're looking at this.
So the bounds are -1 and +1, and if it's close to -1, then it's a strongly negative correlation. If it's close to 0, then it's a weak correlation, and if it's close to 1, then it's a strongly positive correlation. It measures the the strength of the linear association between two variables x and y. Does that sound right?
No?
Yes.
Okay.
Sounds good to me. It's the R value.
Right.
Okay, question 2. Stretch the graph to 10 x and y coordinates and on an x minus y plane, where does the data have a strong linear positive correlation?
Okay.
X minus y, what does it mean by, I'm not quite sure what this is talking about.
I think it's all it's asking to do is sketch yourself
Your own thing?
There you
Oh,
go.
and if you stretch it out, it gets less, it looks less strong or less. I imagine you're just spreading out the points more and more.
Yeah. I was thinking all they want you to do is to be able to identify what a strong linear or positive correlation looks like. So you can make it look pretty much whatever you want.
Yeah.
Here's mine.
Oh, other Jared just joined.
Hey, Jared.
Hey.
How's it going?
Oh, all right.
Excellent. Okay, so we move on to part 2.
I like your graph, Jared.
Thanks. I just Woo! Yeah.
Look at that. Look at all those points. Ooh, you got an outlier there.
Yeah.
That's my test score right there.
That's test scores. Let's do a little bit of. Yeah, that's our group right here. Yeah.
Yeah, I like it. Cool.
Well, I'll go. I actually kind of did this already, part 2, but so you get the Uriel crocodile data, and you enter it into the linear regression, and you come out with a correlation coefficient of 0.986.
Yeah, I got the same thing.
Mm-hmm.
But the covariance was not what they have in the answer.
Nope, I got a different value too. I got 1,533.734191.
What?
What did you get? I got 1,533.74734.
Yeah, you said 1,534, and I was like, oh, I get what you mean, 1,500.
Yeah.
I thought and then 134. I'm like, no.
I was halfway through the word and then realized I was saying it in a weird way.
Cool. And then they already brought it for you, so you can just copy and paste that in there.
Yep.
And it looks like a strong positive linear relationship.
Okay, that's what I got too.
Real quick, this is for the estuarian.
Oh no, it's the estuarian is in the text. You have to pull the Gharial, Gharial crocodile data.
That's why I'm like, I didn't get those same numbers. That makes almost sense now.
You know how the video said you can actually calculate the covariance with Excel, just with the formula?
Yeah, right, yeah.
Well, I figured it out, and I did it so this Excel is like exact to make sure that that answer was right.
Yeah.
I still don't know where the heck that covariance came from, because it's not, 1534.
Well, I don't either, because if you look at the answer sheet, the covariance is right, and both of the standard deviations are right, according to the spreadsheet we're using. But the answer is wrong. I think they just did the math wrong.
Yeah. The problem when you do things by hand,
Yeah,
the solar machines do it for you.
absolutely.
No logic.
So I got, let's see, covariance 1533.73.
Yeah, that's what I got too.
This thing somehow rounded up somewhere.
Yeah, and then had 3 decimal places that were wrong too.
Yeah. Then R value, same R value.
Do you
I don't
think?
get why they
Go ahead.
things are wrong. It's funky.
Yeah, I don't know. The parentheses wouldn't make any difference, would it? Not in multiplication.
Nope.
I don't think so. All right.
It would help.
Yeah. Okay, should we do the quiz?
Yeah.
Well, that was an awesome little homework assignment.
Yeah, that was. It's taxing.
Mhm.
You got to use the Old Faithful data, I guess, for the quiz. It's in the bottom, that attachment.
Which I actually have in my thing already.
Yeah, so do I.
Or had, just kidding.
Oh yeah, I did before I put the crocodile junk in there.
You also have to use the math self-sufficiency one.
There you go. I got it. If you just want to use mine.
I already did the test, so if you guys want to just go ahead and double check, make sure that's, I'm pretty sure we'll get it right. But if it's
So first one, strengthen linear relationship.
direction and strength of the linear relationship.
If the correlation coefficient is negative when one variable increases,
The other tends to decrease.
yeah, it'd have to.
Yeah.
Wait, if the other one increases, yes.
So it's like the miles in the car versus the price of the car.
Right.
The more miles on the odometer, the cheaper it is. So as one goes up, the other goes down.
The effect of outliers on the correlation coefficient is not significant. That is false.
Correct.
Sorry, what was 4 again?
4 was the other variable tends to decrease.
Like,
Correlation coefficient is the R value, right?
Right.
So it's 0.901.
That's what I got too.
Mm-hmm.
Covariance, filtration, and weight
13.9.
of Old Faithful is 13.945.
Yeah.
And they only want one big enough.
13.945.
And just 13.9.
My graph looks like none of those.
Oh,
What?
that's not, it doesn't have anything to do with it. We use this picture to answer questions 8 through 13.
Oh, I see. So that's
What do we have? Oh,
C. R value of 1 is going to be A.
Mm-hmm.
R value of -1, D. No, oh my gosh, this is so annoying. I have,
okay. So 8 is an R value of 0. Is that C?
Yeah.
Okay.
from my one class, that's medical terminology, I've had to like type in a bunch of words,
Oh,
and it
yeah.
keeps highlighting them or like prompting them. So every time I can see, it's like, do you want to use crin/o?
Yeah, that was a fun class. Glad that's over.
Super 9. Okay, and then 95 is going to be B.
So let's see. 10 is D, right?
Yeah.
Yeah, it's alphabet.
Oh, okay. The numbers are on the top. Okay, so C, A, D, and then 11 is,
Does it matter if they're capitalized or not, you think?
I don't know.
I didn't capitalize.
I put capital letters.
Okay. So then R is B, and I'm sorry, 11 is B, and 12 is E.
Uh-huh.
What the hell? I gotta get other data before we open this thing.
So that means 13 must be F.
Yep.
Oh, wait a minute. They didn't tell us to open up math self-efficacy.
Nope. You know what's funny though is that they're starting to just be like, okay, pull up this thing, plug it in, and tell us the answer. I think that's super funny.
Yeah. Remember the first few weeks where we were, working with formulas and calculating stuff, and not anymore.
Oh, I bet you. What the first question does it just ask for females, and the second one they ask for males? Because there's males and females, are they supposed to be the same data?
I don't know.
It doesn't matter now, It's all included. So they're comparing the score, let's see, between the score and the confidence.
Oh.
And confuse both male and female.
Okay, and this.
So the score is the explanatory variable? Is that right? And the confidence is the...
Okay, did you guys get 0.729 for the correlation coefficient?
Yeah.
And this thing is 11.209.
0.729 and... You got 11.2, or how many decimal points do they want it?
3.
11.209, correct?
Yep.
Yeah.
11.209. Cool. All right.
That's 100%.
Did you already submit yours, Jared? Go.
I won't let you guys go astray.
Sweet.
Hey, well, good job, everybody.
Yeah, thanks. Hey, if you have any questions or need any help this week on the what is it? Analyze the data?
Describe the data.
Describe it. Thank you.
Yeah, I'll look into that probably like Friday.
All right.
But yeah, I think it should be pretty self-explanatory. We'll just look at it.
Should be fine.
And look out for it.
Cool. All right. Thank you.
See ya.
See you guys. Have a good night.
Yeah.